Alright, I apologize for the second video. I totally missed the reflect questions and when the baby started crying. So let's go ahead and get these done, and we'll do the try on your own, and then you'll be done. Suppose the inequality in part A is absolute value of x plus 3 plus 1 less or greater than or equal to 4 instead of just greater than. How does that change the solution? Well, that means that the endpoints now actually get included in the solution because we actually have the equal to part. So the solution includes the endpoints. So that means that the new solution would be x less than or equal to -6 or x greater than or equal to 0. In part B, what is another way to write the solution? X greater than -2 and x less than 6. Okay, so let's talk about this. Because this is an and, it's a sandwich function. So it's the other way to write something like that would be you can sandwich the inequalities together, just like when we learned how to write that set notation a few weeks ago. So we could rewrite it, as -2 less than x less than 6 is another way to write an and. And then discussion. Suppose the graph of an absolute value function lies entirely above the graph of the constant function. What's the solution of the inequality? And what's the solution of the inequality for less than? So let's talk about the first one. Absolute value lies entirely above the constant. So the situation that they're talking about is here's my absolute value, here's my constant. If we talked about what the solutions would be everything above it. So therefore it would be an all real solutions. So, or all real numbers. So for f of x greater than g of x, the solution is all real numbers when f of x lies completely or entirely above g of x. And then the other one was the solution of the inequality f of x less than g of x when let me just double check. Okay, so then the other one would be something like this situation, is the way I'm envisioning it, is like that. So really there isn't a solution, because if we're talking about the inequalities being, or the solutions being above that line, there's nowhere where those things intersect. So we would say that for f of x less than g of x, there is no real solution. Because f of x lies entirely below, entirely below g of x. All right, let's try one together. All right, so we basically need to solve it by graphing. It looks like we get to include the solutions. Remember, this is your F graph, this is your G graph. So I'm just going to go ahead. They didn't give me a little plot, so I'm going to give myself a plot. I'm going to have to be really, really careful on my scaling. So the vertex on here, you change the sign, you keep the sign. So we're going to plot -1, positive, or -4. And then we have to graph the slope in front is, slope in front, oh, it doesn't like me touching it. Here's a 1. So I'm going to count up 1 over 1 in both directions. So up 1 over 1, up 1 over 1, up 1 over 1. We got to get to -2. We're plenty. Okay, so let's go this way a little bit. So up 1 over 1, up 1 over 1, up 1 over 1. So there's the v here. And then we need my funky little bar at the bottom, sorry. All right, then we need to also graph -2, which is going to go through here, which means these points here that I missed are my solutions. So what we really want is the numbers. So since the F graph has where the F graph lies below the G graph, so it's these values in here are our solutions. So it's between these two numbers and including those two numbers because we have the less than or equal to. And since it's between the two things, it's an and. So we would say that it is -3. So x is less than or equal to sorry, not less than. It doesn't like that. Let me get rid of that. Nope. Not without erasing. We're just going to cross out. Okay. Ignore that. So x is going to be greater than or equal to -3 because it's got to be bigger than -3 and it has to be smaller than the 1. So x is less than or equal to 1. Now you can go ahead and start your assignment.